Hi everyone, I hope you can hear me. Then I will start with a short video introducing our office and what actually we offer. Then I will dig deep into details, giving you an insight about what we offer and what we actually manage to achieve. So starting from this, telling simply our story.
Mein Name ist Alamir Mosen. Ich bin der Gründer von Lithium Designers. Wir ermöglichen die Massenproduktion von individuellen Konstruktionslösungen für den Bau von Freiform-Gebäudehüllen. Immobilien und andere Bauwesen sind bekannt für deren ineffiziente Planungsprozesse, dessen zeit- und kostenintensive Entwicklung und den Materialverlust von bis zu 70%. Und genau dieses Problem lösen wir. Wir haben eine innovative 3D-Druckdesign- und Planungslösung entwickelt, die den Immobilienentwickler einen vollautomatischen Planungsprozess ermöglicht, welcher zeit- und kosteneffizient ist, mit 30 bis 40% weniger Baukosten und über 85% weniger Materialabfall liefert. Wir verfügen über 10 Jahre Entwicklungserfahrung, 11 internationale Auszeichnungen und Patente in Europa und den USA. Wir sind die Ersten, die in Deutschland und weltweit erfolgreich 3D-gedruckte Elemente für die Bauindustrie zertifizieren. Als nächstes werden wir unsere Zertifizierung auf ganz Europa, den Nahen Osten und die USA ausweiten. Unsere Vision ist die Massenproduktion von individuellen Lösungen.
So let's go to the problem. What we have at the moment in the planning and the design of freeform facades and building envelopes is a huge problem because we have an ineffective planning processes, which is time and cost intensive. We talk about 3,000 euro per square meter. And when we discuss CNC parts, we talk about over 70% material waste. So we need to have a new solution that express the market a sustainable a new way of planning freeform and large-scale projects. And here we offer our solution, which is kind of like a fully automated planning process, which is time and money saving. And we talk about a square meter price around 1,000 euro per square meter, less than 5% material waste, and 80% reduction in CO2 emissions. So how we achieve this, what we call is LE3 method, consists of two main parts, which is our software and our 3D printed nodes, and it's been done and executed by us. So our 3D printed nodes, you can see one node here in my hand. So the main idea is we have a fully 3D printed topology optimized node. So we have only the material that we need for a certain loading condition, not more, not less. And the only waste that we can see would be the support structure of these nodes, and this is really pretty minimum. The next part would be our software. So what we managed to do is to eliminate the complexity in freeform geometries and facades, and we just take the geometry as a base and we transform it into a Lego-like structures. So we break down any sophisticated geometry into small parts that can be just simply connected together. And in this case will be the nodes and profiles and glass. How our software works, you can see here, we divide our workflow in kind of like 4 main stages. So once we have a base geometry, we can start to optimize this according to like manufacturing limitations of 3D printing or glass manufacturing limitations. And then once we have this, we start to break this down into pieces and parts. We get the nodes out of topology optimizations, we can get the manufacturing lists, and we can get from that model all needed information for execution and for building up this project. So here you can see how our software is actually built. We have our core software in C# written, and then we include so many elements in it, like building systems, design constraints, and our coded building elements, which is you have parts that knows exactly where they're going to be positioned in any geometry or in any freeform. So here a short demonstration how our software works. One of our latest concepts showing our software in action. Data. So you can put it in the printer, CNC machine is just ready to use. So let's talk about the projects that we already built. So we start with our first case study project. Hive Project Express, a freeform facade with 134 fully 3D printed aluminum nodes. Here you can see the project after completion. It's been done, it's been ended in the beginning of 2022. Moving from this project, we've been commissioned with one of the largest glass freeform roofs in Europe, and this project is in Hamburg. In this project, we managed to automate the generation of 9,000 nodes, 20,000 different profiles. Here you can start to see how the project starts to come together on site right now. We have 34 columns like this, and they've been under construction at the moment. And at the end comes a glass and aluminum level, and we have a fully automated process done with our software for this unique project. So let's go to one more topic, which is sustainability. So let's compare a simple thing, how we work traditionally right now for such geometries and freeform building envelopes, and what we can offer into the process. So we took, like, let's say, an assumption of a building, and we said, okay, if we're going to work on this traditionally, we're going to need around 100 tons steel and aluminum. Compared to this, just replacing this with our automated planning and 3D printed nodes, we can go down with the material usage to 20 tons. So we talk about 80% material reduction, and this expresses a huge and enormous saving in CO2 emissions. We have a patent in Europe, in USA. Talking about certification, we got project-specified certification for our case study project Hive, and we are developing right now our certification like ABZ, which is the global, let's say, international certification process as a German product. Our last cooperation, which we are glad to announce today, was Tecnal and Wicona by Hydro as facade system providers, and AM Global and EOS. And the mocap you can see on the booth of EOS. And For this, I would love to show you the idea behind that concept in the last video. This is my last slide, and this is just a collection of awards that we received in the last 5 years since founding the company. Thank you so much for your time, and I'll be glad to answer your questions if there's any. Thank you for being here.
Any questions from the audience? Nothing, and nothing on Slido at this time, which is probably okay because we are running quite late now, unfortunately. Thank you very much for your presentation, much appreciated. Will you be around at the exhibition?
Yes, yes. The mockup is in EOS booth. Please feel free to pass by and check it out. And there's a lot of notes to see and touch and see what we can achieve. Thank you so much.
That's on EOS?
Yeah.
Okay.
Yes.
Yep. So any more questions, head down there, go and touch and feel the parts for yourselves and see what it's all about.
Thank you.